Hey everybody, welcome to my final video of the 2020 school year. I miss you guys. I know that doing these has been aggravating, but it's really the best way to prepare if this is your last one. So without further ado, I have to say, I don't know, hopefully you guys are doing this before watching the video or whatever, but this is the easiest AP exam I have ever taken. So, yay. I don't know what they were feeling in 2019, but they were super friendly. These problems are all very easy. Okay, so based on the histogram, write a few sentences describing the distribution of room size in the residence hall. It's a histogram, so I did socks. I pretended that I could not see these summary statistics. You can actually use them according to the scoring guidelines, maybe if you put the median or the mean, but I just went off the histogram, and the scoring guidelines say that either one is fine. So shape, bimodal, and roughly symmetric. Notice there's two peaks here. No outliers shown on the histogram. Because it was symmetric, I used the mean. I said it was located between 200 and 250 square feet of room size, just somewhere in here. And then spread, I did range of 350 minus 100 equals 250 square feet of room size. And I couldn't do anything else because it was a histogram. Now technically I could, again, use these, but it said describe the distribution based on the histogram, so I just pretended I couldn't see these things. Okay. For this section, you will get an E if you have these four components. You need to say it's bimodal, or there are two peaks or two clusters. You need to say the center is between 200 and 300 square feet. You can say mean or median. Just say the sum center is between 200 and 300 square feet. The spread is, you can say the range is somewhere between 150 and 250. I did my range was 250. Or the IQR is somewhere between 50 and 150. Or all room sizes are between 100 and 350. And then there is some context included, so that's where I have my square feet of room size. I certainly learned my lesson there. Okay, you get a P if you have two or three of those four components. And then if you just have one of them, that's an I. Okay, section 2 is this outliers part. You need to have computation of the upper and lower boundary fences. So 174 minus 177 and 292 plus 177. So there's my 292 plus 177 is 354. 174 minus 177 is -3. You have, and this is the 1.5 times IQR rule, you have a correct decision regarding the presence of outliers, so I have no high outliers, no low outliers, and then a correct justification that compares the data with the fences. So I said the max is 315, so no high outliers, min is 134, so no low outliers. So you've got the correct calculation, you've got the comparison of that to the max, and then you have a decision made about outliers there. You can get a P if you have two of the three components above, or if you omit exactly one of the fences but otherwise satisfy all three components. So you just do the high or the low. I is anything else that doesn't satisfy that. Okay. And here is my box plot. You get an E for this section if you have a correct sketch of the box plot. Mine's correct. And a response for part C that indicates the bimodal shape is apparent in the histogram but not in the box. in the box plot, so bimodal. Okay. And that's it for question 1. I don't even know, people. So easy. Fantastic. And you guys, if any of you missed it, I'm very sorry. I don't mean to be rude in any way. It's just, that was a glorious question. Okay. Alright, question 2. I have, the treatments are the different sprays of mixtures, 0, 1.25, 2.5, and 3.75 milliliters per liter. The experimental units, I have an equal number of insects in 20 individual containers. The response variable is the number of insects that are still alive in each container 1 week after spraying. I hope that you guys don't have one word in these, that you don't have sprays, bugs, and whether or not they're dead or something. I hope you have a little bit more explanation, but let's see what they want. Okay, part A is scored as follows. You get an E if you identify the 4 concentrations or mixtures or sprays as the treatments. So you say 4 mixtures, 4 sprays, something like that works. Identifies the 20 containers as the experimental units. Okay, I didn't put exactly that. I put an equal number of insects in 20 individual containers. That is accepted later in the notes, I noticed, because I was thinking the insects are the experimental units, but because I included that, it's fine. And response variable is the number of insects that are still alive in each container. Partially correct if you have 2 of the 3, incorrect if not. Okay, listing the 4 treatments satisfies component 1, including milliliters per liter, is not required. You could just say 0 milliliters, 1.25 milliliters per liter, 2.5, 3.75. Okay, hold on. So this is the note I wanted to point out. The 20 containers, the 20 groups of insects, or the group of insects in each container all satisfy component 2. References to only group of insects do not satisfy component 2 because it is unclear if they are formed by treatment or by container. So you have to say that they're in containers. A response that says only number of insects alive does not satisfy component 3 because it could be referring to the total number of insects alive. So you need to say alive in each container. Okay, you knew they were going to be specific. Okay, B, interesting note for B on the scoring guidelines. I put, does it have a control group? Yes, the spray with 0 milliliters per liter will not contain any fungus mixture, and insects sprayed with this will be the control group. Okay, so that's what I said, which is an acceptable answer. Hopefully you can see. Oh, there we go. Okay, this is interesting, I think. You get an E if you indicate there is a control group and justify it by identifying the control group, which is what I did, or explaining that there is a treatment which contains no fungus. Okay. I think that's mine. You get a P if you say there's no control group because every container is sprayed with some mixture. So you can actually have it wrong. You can say that there is no control group because everyone gets sprayed with something, and so you still get a P for that, which I find interesting. Or if the response states that there is a control group but implies that 0 milliliters per liter is not a treatment. So technically they do still get sprayed, so they do technically receive a treatment. So that's a P anyway. I'm hoping that you guys put the same thing as me there. Okay, now C, I'm really glad this one came up because I'm not sure, I have a feeling that some people probably just did this and not this part. think this part is actually extra. This part is the part that's necessary. So describe how the treatments can be randomly assigned. So you're actually describing the random assignment part, how you're doing it, to the experimental units. So each treatment has the same number. Okay, I know that everyone's going to know they have 5 each. But what you need to do is explain how you get it. So first of all, you have to say that you number the containers 1 through 20. And you can do this in 2 different ways. There's actually 3 different ways. You could do the table of random digits also, but I know how we all feel about the table of random digits. So this is the simplest one. Put slips of paper in a hat numbered 1 through 20. Pull out 5 slips for 0, 5. The next 5 will be 1.25. The next 5 will be 2.5. And the remaining 5 will be the 3.75 milliliter per liter group. Or you can use a random number generator to choose 20 unique numbers out of the numbers 1 through 20. So basically just ordering them. I put example random integer no repeat 1, 20, 20. The first 5 numbers will be the 0 group. The next 5 will be the 1.25 group, and so on. Okay, so you need to have 3 components to get an E for this. Creates appropriate labels for the units treatment, so label the containers 1 through 20. Describes how to correctly implement the random assignment process, and the random assignment process results in an equal number of experimental units. Okay, so notice that they give us some options. They give us slips of paper, oh, look at this. I think I got a P for this because I did not say that they're not mixed or selected at random. Okay. Well, as you can see, I do this without reading the guidelines. So I did not say that they were mixed between. Interesting. Okay. However, what if I put both of these in my answer? Would I get an E then? Don't know. Okay, so here's my random number generator. Here's my without replacement. Yay, I got that one. You could also use a 20-sided dice in this case. Table of random digits, I mean, you know. So what you would do is say that you would have a randomly selected row and then go every certain number. I just don't see any of us doing that. These are my 2 favorite. Now just gonna put in here for future reference, but you can tell I did that one wrong. Well, not wrong, just not perfect. And that is okay. Because College Board, you know, is special. Okay, here you go. This is a great one. Your probability stuff from chapter 3. Another really great chance to practice this with the tables. So this particular problem really didn't even require any work. You get an E if you get the correct 3 answers. So 0.0636, 0.5864, and 0.12 for part A. So really, it didn't even say work. It just said essentially correct if they report correct values of the probabilities for 1, 2, and 3. If you have 1 or 2 of them correct, you get a P, and if none of them are correct, you get an I. Okay, now for B, there are actually 3 different ways to show independence. You can do this way, show that this 0.12 off of this part of the table here is equivalent to the 0.12 calculated there, and then you need to make a decision. So Here are all of your options. Okay, first, you get an E if you say they're independent. You have to give an explanation of independence using events in the problem. So this type of style of probability notation. And then you provide appropriate justification using numbers from the table. So you actually have to plug things in. You can't just say, yes, P of n equals P of n given W. Like, that's not good enough for them. You actually have to plug in things from the table. Okay, so there's 3 different ways you can do this. You can use the multiplication rule, which says woman and never is the same as woman and never multiplied together. That's probably the easiest one. And then you can do either of the 2 conditionals. Never given woman is equal to never, and that's what I did. Never given woman is equal to never. Or you can switch it around and do woman given never is equal to woman. Just note, this will save you time. Remember that in the conditional, the one in the front needs to be the same as the one that's by itself. So the one in the front needs to be the same as the one by itself. Okay. You get a P if you say that they're independent and you use the notation, but you don't plug in numbers. Or if you make an arithmetic mistake or a transcription mistake that results in you concluding that they are not independent. Okay, and then C, last one here. I have a binomial. I have my random variable notation. I have labels because I've been learning my lesson as we go. They want all of this stuff labeled. Okay. You get an E if you clearly indicate a binomial distribution with n is 5 and p is 0.54. So I have binomial n and p. Indicates the correct boundary value and direction of the event. So I have boundary value and direction here. And then reports the correct probability is the last piece. If you have component 1, so you show binomial with n and p, but you don't have either one of these or both of those right, then you get a p, which is nice. So you could do the wrong binomial, you could do just binomial CDF or put a 4 here on accident, you could still get a p. Notice I have ridiculously labeled everything. And if you do the correct boundary and report the correct probability, but you don't specifically say that it's binomial, you can still get a P. I wanted to show you the solution very quickly. The solution did not have binom CDF. It had the 5 choose 4, 0.54 to the 4th, 0.46 to the 1, and 5 choose 5, 0.54 to the 5, 0.46 to the 0. So this is your 4 and this is your 5 just added together. So you don't need to do binomial CDF, but I'm sure most of you did binomial CDF there. Okay, question 4. The big question here is, did you remember to pool? And I know just some people went, ah, dang it. Okay, so you have a 2 independent sample difference in proportions test here. Sorry. And notice I have my labels. So we're going to go a tiny bit slow here because the section scoring is weird. Okay. Notice here, this is fun. So this is what happens when you do this really early in the morning after your son goes and gets his graduation photo and video done, and you think you're highlighting something important, but the whiteout is in your hand. Yes. Okay, so you get an E for section 1. You need to have components 1 and 4 and at least one of 2 or 3. So this is kind of confusing. You don't have to have all 4. You need 1 and 4 for sure, and then either one of 2 and 3 because you probably didn't do both. Okay. Number 1. Hypotheses imply equality of proportions in the null and correct direction on the alternative, and utilize an appropriate population parameter in words or symbols. Okay, so what does that mean? It means I have equality here. Come on, focus, you can do it. Okay, you have equality here with subtraction. Notice I'm using the appropriate symbols, P. I have greater than here with subtraction. Now, if you have your 2014 in front and your 2017 in second, you should make this less than. That's still fine, and you'll get the same answer in the end. I just like my numbers to be positive, so I made this 17 minus 14. And that's number 1. Number 2, identifies parameters that are population proportions. Okay, so I did that over here. P 2017, the proportion of all plants, I don't even know, Cochia? I don't know. Plants resistant to, oh, look at this, glyphosate. They got all the words going. Okay, so there's my definitions. It says, both parameters are clearly defined as population proportions in 2014 and 2017. So I did both of those in one over here. And then a 2-sample z-test for proportions is identified by name or by formula. So that is this here. Okay. So for this, it's all the identify and then just kind of knowing that you know which test to do from your calculate. Okay, now section 2 is also strange. So it's the 3 conditions, a correct z statistic, and then a correct p-value. So random samples for the random condition. So you need, this is really interesting. Okay, so you get an E if you have 1 and 2 and at least 2 of the others. And then you get a P if 2 of the 5 components are satisfied. So this is tricky to grade. But I'm hoping that you guys have all of this. So you have randomness condition checked. You checked for appropriate normality by showing the expected number of resistant and non-resistant plants are both larger than 5 or 10 for both samples. Notes that the population of plants must be extremely large and thus satisfies the 10% condition. Reports a correct value of the z-test statistic. Records a p-value that is consistent. Okay, so I have 2017 here, 2014 here, which is why this is all whited out, because I accidentally wrote the 2014 stuff there and the 2017 stuff there, because I'm special. And again, did this right after coming back from graduation filming, and I was really tired. Anywho, okay, so both randomly selected, check. I have 52 times 10 equals 520 less than all plants in 2017. Cochia? What plant is that? What plant is that? Can somebody send me a picture of a cochia plant, please? Oh, tumbleweed in the end of the summer. Oh, that's right. Anywho, okay. And then I have 61 times 10 equals 610. Okay, and then for the normal condition, I have n times p equals 20, greater than or equal to 10. N times p equals 12, greater than or equal to 10. Okay, so that was the first 3, and then the z-score being here, and the p-value being here. Notice I've got all my stuff labeled because I've learned my lesson, and I've got my pooled over there. Okay. Section, and so, you know, if you get this wrong, then this is going to be a P because you forgot to pool. But as long as you use your incorrect work here, you'll still get a P. It's okay. Okay. Last section is all about the conclusion. So compare between p-value and 0.05. Correct conclusion consistent with the alternative hypothesis in context. So less than 0.05, reject the hoe, and then basically I just come back here and rewrite this sentence. So there is statistical evidence that there has been an increase in the proportion of all cochia plants that are resistant to glyphosate. Alright, if you just write this the way that you usually do, then you will get an E with no worries. Okay, last one. And if there was a tricky one, it was number 5. Here's another reason that it's tricky. First, you should probably do A first and then B, unlike your teacher, who did B first and then A. And then said, you know, I'm not going to make this video right away because I'm so tired. Anyway, okay, so 25% of the batteries no longer work, so that's going to a percent, which is inverse norm. So I have inverse norm 0.2538 equals 24.6 months. Notice I've got labeling percentile, mean, standard deviation, and context in the months because I have just learned my lesson. Okay, E, if you get the following 3 components, indicates use of a normal distribution with mean of 30 and standard deviation of 8, check. Sets up a correct approach for finding the 25th percentile of the battery life distribution, so that's inverse norm, check. You can also look it up in the table. Reports the correct value, 24.6. You get a P if you have 2 of those 3, and then I if you don't have those. Okay, I'm hoping everyone got part B at least. Indicates the use of a normal distribution with mean of 30 and standard deviation of 8. Good. Correct. Specifies the correct event, including the correct boundary value and direction. So that means this. Your random variable notation. Don't forget that, please. Reports the correct probability, 0.2266, or probability consistent with components 1 and 2. So you can also find that through a table, is what they're saying. If you have 2 of the 3 components, you get a P. So notice I've got everything. I've got my random variable notation. I started labeling those because I read the keyboard tips for the 2020 test, and they wanted all of this labeled, so I did so. And there's my final answer. Okay. Last one, you guys. Okay, part C provides an expected value calculation with 2 appropriate probabilities that add to 1 and are paired with the correct outcomes. Reports the correct expected value of 4.68 or a reasonable expected value consistent with work shown. And P if you have only one of those 2 components. So I set up my table like we usually do. The value of the gain is on top, so I have 50 and negative 150. The negative 150 is the needs a replacement, so that's the probability that we found in part B, so that goes there. And then not needing a replacement is going to be the opposite, the complement of that. So I did 1 minus that to get that, and then top times the bottom plus the top times the bottom is $4.68 gain for each warranty purchased. Okay, everybody, that's it. I am hoping that these AP questions for this year will be just like these from 2019, because I really liked these personally. I'm hoping that you guys are feeling like you're ready. Do the sample question, and that is your last assignment of the year. We will not be doing any further classwork or project or anything like that. You probably won't even hear from me except for silly jokes or something like that, maybe. If this video is being watched any year other than 2020, I'm sorry, there probably is more work to do because you'll have more years to do. Hopefully I won't be mean and start them on 2014 though. Anyway, hope you guys are great. I'll talk to you soon. Hope to see you somewhere and wave, and waiting for all of my hugs when I can get them. Thanks everyone. Bye.